In this video, we're going to be given the graph of a given function g of x, and we want to determine if the limit as x goes to 3 of this function exists. If it does, we want to give the limit, otherwise say it doesn't. Now before we get to the first one, let's look at this statement right here. The limit of g of x as x goes to a, we say equals to some number L. That's the limit. If and only if the left-hand limit and the right-hand limit are both equal and they're equal to L. So if we look at an example here, let's suppose we look at this x-axis here, and let's say that's the open point A, and we're simply looking at this part of the line. We can extend it either way. So if we look at the limit as x approaches A from the left side, that's this one right here. That's the left-hand side. We're coming from the left side at that point. You notice that stays on the x-axis. So the value from the left side at x equal to a is 0. From the right side, coming from this side, again, that's also equal to a. Now since I have an open circle here, this function is actually not defined at that point. It has an open hole there. But that's okay. If I shade it in like this, if I include that point, the limit will still exist from both sides. So this is going to exist. Now if I have something like this, where let's say this comes this way, and then if I go, say, 2 units up here, and this one is open here, and then it goes to the left, like that. The limit, I can say this then, the limit as x goes to a. And let's say this graph is g of x from the left. Okay, so from the left, I'm up here. That's 2 units. So from the left, this would be equal to 2. And from the right, the limit as x goes to a, the plus sign means from the right, negative means from the left, of g of x. In this case, we're over here, this would equal to 0. At x equal to a, the value of the function is 0. Now if I make this an open circle here, that's still the same. But either way, these are not equal. It's not the same thing. So the limit in this case would not exist. So now we can go a little bit quicker through these. So let's look at this one here. I want to find again in these, I want to know what is the limit from the graph x goes to 3 of that function based on that graph, g of x. So let's go from the left side. From the left side, we want to know the limit at x equal to 3. So here's the value of 3, and this graph is coming down this way. So it goes to infinity. It doesn't even have a value there. Now the limit from the right does exist. Coming in from the right, we go up. We get real close to 3, go up. That's 2 units. So the limit from the right-hand side, that's the plus side, does equal to 2, but this symbol means exists. This means it doesn't. So the limit does not exist for this one here. It does not exist. Now for the next one, let's do this. Let's say we have, this is open here, and that goes that way, and that goes that way. So we go 3 units this way. This is a little bit off, but that's supposed to be right above this 3 here and to the right of 2. So in this case, we can say the limit as x goes to 3. This function is now represented by g of x, the graph is. So from the right-hand side, I go up 3, or 2, I'm sorry. And from the left hand, I go up 2. So the limit from both sides is the same, 2. So limit does exist, and it equals to 2. Limit of g of x as x approaches 3 is 2. Now let's go again. At 3, I'm going to go 1 unit up, and it's open. And I have a parabola this way, and a parabola this way. I want to know limit as x approaches 3. Again, the two-sided limit will exist only if the right and the left-hand limit exist and equal to that value. They're both equal to each other. So in this case, I go from the right side coming in this way. That open dot right there, or circle here, point is 1 unit up. So the limit does exist, and it gives you 1 from both sides. So that's 1. Let's go look at the next graph here. It's just horizontal again. And this point is say 3. This one over here is say 5. There's another horizontal segment here right above that one. So this distance here from the x-axis is 3, and this one over here is 5. Well, you can see this one very clearly from if we want to find the limit as x goes to 3 of g of x, we don't get the same limit from the right or from the left. If I come in from the left side, x equals 3 from the left, I have to get close to 3 but not quite there, so I go way up. I get this value, so I get 5. Limit is 5 from the left side. From the right side, I come in here real close to 3. If I go up, I have to go 3 units. So the limit from the left side is equal to 3, and the limit from the right, as x approaches 3, is equal to 3. So no limit for this one, or I can say the limit, again, this means exists, does not exist. For the next one, we'll go 3, 4, 5 here. It's open here so I go 3 over and 4 up. And then at 5, again, right above the 3, 5 units up, the graph goes like this. So you can see the limit as x approaches 3 from the left side would give you this distance right here, which is 4. And the limit from the right side as x approaches 3. Get real close to 3 from the right side. You don't want to get right at 3, real close to 3, and then what is that value? That's 5. So I get 2 different limits from the left and from the right. They're not equal. So the limit does not exist. Now for this one here, we have, okay, for the last one here, we have a vertical line, and this is supposed to be x equal to 3. So that means the graph cannot cross the vertical line. So it approaches it from each side. It approaches from infinity from each side, positive infinity. But that doesn't give you an actual value or a number for the limit. So again, we say no limit exists. Thanks for watching. We'll see you next time.